Okay, for section 7.3, solving quadratic equations by graphing, if you can remember back to grade 10, you would be given a question like this: 2x squared minus 5x minus 3 equals 0, and you would be asked to graph it, or to solve it, sorry, not to graph it. What we're going to do in grade 11 is solve it using graphing, but I'm going to show you the first way by algebra. This should look familiar from grade 10. So the first thing I do is I multiply the 2 and the negative 3. I get negative 6. I need two numbers that multiply to negative 6 and add to a negative 5. So if they're multiplying to a negative number, I know one of them has to be negative and one of them has to be positive. Factors of 6 are 2 and 3. 2 and 3 do give me 5, but there's no way I can get negative 6 from 2 and 3. If I get 2 and negative 3, that gets me negative 6, but 2 negative 3 doesn't get me 5. So I know right away that it's got to be negative 6 and a positive 1. They multiply to negative 6, add to negative 5. If I'm splitting up the middle term, I need to split it up into my negative 6x and my plus 1x. So that this becomes 2x squared minus 6x plus 1x minus 3 equals 0. And then what I do is I look at the first two terms, the 2x squared and the negative 6x, and I say, what's common between those two? Well, I know that a 2 and an x is common. If I divide 2x squared by 2x, I'm left with x. If I divide negative 6x by 2x, I'm left with minus 3. The next two things, the only thing that's common is a plus 1, and I'm left with an x minus 3. This is good because I want x minus 3. Then I have x minus 3 common, and 2x plus 1 left. Remember that this equals 0. And then I have to solve. So my two values are, I can do this, x minus 3 equals 0, or 2x plus 1 equals 0, and I solve each one. In this case, x equals 3. In this case, I move the 1 over so it becomes negative 1, then divide by 2, so x is equal to negative 1 over 2. Those are my two values. Okay? And that's solving using algebra. Solving using algebra. The next way that we're going to learn is solving by graphing. So I bring up my graphing calculator, and I go to my y equals window, and I plug in this graph right here, my 2x squared minus 5x minus 3. So 2x squared minus 5x minus 3. Make sure my window settings are set. Yep, they're good. Okay, so that's pretty good. I get a picture of the graph that looks something like that. I can copy that into my window. It's got the low point at about negative 1, 2, it's hard to see here, 1, 2, 3, 4, 5, 6. So we're at the bottom, should be in the middle between the two. So 1, 2, 3, 4, so 1, 2, down at the bottom. And I get a picture of my graph that looks something like this. Now, the way to solve this using graphing is I want to figure out where this graph equals 0. Well, where the graph equals 0 is where the graph crosses, if you remember from the last lesson, where the graph crosses the x-axis is my zeros. So I go to my graph, I go second, calculate, and I want to calculate the zeros, so I go down to 2, or you can just press 2. And again, it brings you the left bound, so I need to go to the left of the first 0. Here's the first 0 here, so I'm going to go just to the left. Make sure you go to the left, and I'm going to press enter. Right bound, I have to go to the right of that 0, as long as I'm to the right. And I press enter, and then enter again for guessing. And it gives me an answer of x equals negative 0.5. So I get one answer of negative 0.5, 0. That's my first 0. My second one, again, second, calculate. I go down to 0, and I calculate the one over here. So left bound, I'm going to have to be to the left of that 0. So there's the 0, and then to the left is just below. The right bound is going to be above a little bit. Press enter. Guess. Gives me an answer of 3, 0. Notice that my two answers here are the same as here. X equals 3, yep, and x equals negative a half, yep. So I have both my zeros, and I found them using my graphing calculator and using the calculate button. Okay, next example. This is from page 373. In these types of word problems, you need to be able to interpret the question to understand what's being asked. So basically, you need to understand what is happening in the graph and how that relates to the real world question. So Bonnie launches a rocket with a trajectory modeled by -4.9 t squared plus 68 t. It says, when will the rocket be at Sasha's eye level of 72 meters? So there's two functions we need for this one. The first one is this one, the h of t, which I'm going to have to graph. So I go y equals, clear that one, -4.9. Now notice how it's t, and I have x, comma t, comma theta. Any variable that you have, just use your x button for. So -4.9 x squared. Don't worry about the t, it's just a variable, right? So plus 68x. And just graph that to make sure that I can see it in my window. Okay, this might be a good idea to go zoom and go down to zoom fit, 0. Okay, getting there. It doesn't quite go over far enough, so I'm going to have to change my window on my X to go to, say, 30. Let's check that out. Good, perfect. Now I get a good, clear picture of what my graph looks like. So just check your window settings. It goes from -10 to 30. So from -10 to 30 on my X. And then on my Y, it goes from -1,170 to 235. It's okay that the values are big because we're dealing with quite large values, right? Plus 6018, it's a rocket. And there is what my graph looks like based on those values, right? My window would be a little bit different than that. I should actually have my lines going maybe like this and like that. Okay, and then check to make sure that your graph looks similar. So it's going to go up and then come back down. Yeah. So you got a picture of your graph. I got my window settings above, 235, -10 to 30, and it goes down to -170. My y equals is exactly what I have there, so it's my -4.9 x squared plus 68x. Now, the second part of this is, when will the rocket be at Sasha's eye level of 72 meters? So what I want to do is I want to go down to my y2. I just press down. And then in my y2, I'm actually going to plug in 72. And then hit graph. Notice how it puts a straight line across. And that straight line across is where Sasha's eye level is. She's at the top of a mountain or something. And we have to figure out when the rocket will be at Sasha's eye level. Well, it's going to be at Sasha's eye level there and there, which are where the two lines intersect. So what I want to do is I want to second calculate, and I want to calculate this time the intersection, so number 5. So I calculate the intersection, the first curve. What you want to do is you want to move the cursor close to where the intersection point is. So if you can see, my cursor is up there, the intersection point is down there. Second curve, it should be on the line, which it is, good. And then it says guess. And then it'll tell you the intersection point at x equals 1.15. And notice that y equals 72. That's good because we want the y value to be 72. So if x equals, my second function is y equals 72. And my x-intercepts are x equals 1.15. And I have two. I have another one way over here. So I'm going to have to second function, calculate my intersects again. This time I move the cursor way over, I move the cursor way over to where the other intersection point is. Keep going, keep going, keep going. Okay, so that's close to where the intersection point is. That's on my curve. The other one should be on my straight line. It is. I press enter. Gives me an x value of 12.7. And usually, I think this time is measured in seconds, so it'd be at 1.15 seconds, and at 12.7 seconds is where that straight line at 72, where they intersect. Okay? Last example, rewrite in standard form and solve by graphing. So these ones are pretty easy. You just have to make sure everything is over to one side and set equal to 0. So I'm going to subtract off 11a, subtract off 11a, then I'm going to subtract off 13, and subtract off 13. So I get 6a squared, minus 2a minus 11a is minus 13a, minus 13 is equal to 0. And then you just have to graph it, right? So you go to your graphing calculator, clear it, you go up to the top one, you get 6, and remember that the variable doesn't matter, so I'm just going to still use x squared minus 13x minus 13. Now I'm going to change my window. Actually, let's graph it and see what the window settings are like. Yeah, they're a bit too much. So what I'm going to do is I'm going to change my window. I'm going to zoom and go zoom fit again. Oops. It's going to think for a bit, and then it shows you the graph. Okay, it doesn't quite go down far enough. So I'm going to change my window settings. My y minimum should maybe be negative 30. Y maximum is way too much. It doesn't really need to be that much. Let's change it to maybe 500. Okay, so I can see it dipping below. This is perfect. Now I need to second function calculate, and I calculate the zeros again. So calculate the zeros. My left bound. Okay, it's really hard to see, so I'm going to have to change my window settings again. It's going to have to go down way lower, so like negative 500. Okay, this is hard. So let's change our window settings again. Maybe negative 200. I think the problem is it's going up too much. So let's change my window. Instead of going up to 500, let's have it go to 200. Let's change the x from negative 10 to maybe 15. Let's have it go up to maybe 100. Yeah, let's graph that now. Okay, it's a bit better. So let's second function calculate the zeros again. Left bound, so I'm going to have to go to the left of my first zero. There's my first zero. I'm going to go to the left, hit enter. I'm going to go to the right, make sure it's a bit below as well, or a bit above the zero, wherever it happens to be. Hit enter. It's going to guess. My first zero is at negative 1.24, so a equals 1.24. And the second one, calculate the zero left bound, so I go to the left of where the zero is, press enter. I go to the right of where the zero is, so make sure you cross the line. You have to cross the line. Press enter. And the next one is at 1.74. 1.74. So my two values would be 1.24 comma 0 and 1.74, whoops, comma 0. Those would be my 2 points. Okay, so we solved this equation by graphing. We didn't have to factor it at all. And just make sure you understand how to graph it and how to calculate the zeros.